Okay, so we are going to do solving trig equations, which we just did. The only difference is that we're also going to be using these formulas from our formula sheet. Okay, what I want you to do right now is in this section, I'm going to have us isolate for all three variations here. Okay, so if I want sine squared theta alone, it would equal 1 minus cos squared theta. Can you write that on your formula sheet? Does that make sense? I just moved to isolate. And if you wanted cos squared theta alone, you would do what? You would move the sine over. So 1 minus sine squared theta. Okay, the next one, if I wanted tan squared theta alone, it would equal secant squared theta minus 1. There's always two variations to add here, so then if I wanted 1 alone, it'd be secant squared theta minus tan squared theta. Can you finish that off, the last one with the cotangents? Okay, so sine b equals sine of 2b. I cannot solve this. I need to make a replacement. Okay, is there a replacement for the sine of b on your formula sheet? Is there a replacement for sine of 2b on your formula sheet? Which one has a replacement from the formula sheet? Sine of 2b. Okay. Where do you see it? At the bottom somewhere? Sine of 2, so double the angle, equals this. So I'm going to replace it. Okay. That's the only new thing we're doing. And then other things are all old math concepts that you know. Okay, algebra branch. Remember I gave you that. So, on your algebra branch, do you have one variable to isolate or do you have two variables? What do you think? Two variables. What's the instant first thing you need to do if you have two variables?
Oh, make it equal 0.
Make it 0. So I'm going to move this. Okay, so if you have two variables, you have to have an equation with a 0. Then we go into, can we factor this? That's our next algebra move. So I'm going to process the styles. Do I have a simple trinomial? Do I have a complex trinomial? Do I have a GCF? Do I have a difference of squares? It is one of those four.
GCF.
It is a GCF. So what can you take out of this unit and this unit? What do they both have in them? A sine b. Sine b times what? To make that? 2 cos b. Sine b times what? Subtract 1. So now, how do I make this multiplier be 0 if sine b was 0? How do I make this multiplier 0? if cos B is positive 1/2. Okay, those are called solving for the trig values. That's all you've done. So now I have to solve for the angle. So do you remember your angle process? So when I start my angle process, the first thing is, do I recognize anything from the unit circle? Yeah, 0 is on the unit circle and 1/2 is on the unit circle. So where do you see y values? Sine is y values. Where? Where do you see a y value of 0? Right here and right here, right? So looking back here, well, first of all, I have to be in degrees. So I have to be bigger than or equal to 0 degrees, and I have to be less than 360 degrees. So 0 degrees would be a solution. 180 would be a solution. What do you think about 360? No. It's tricky because it has to be less than 360. So if I had had a or equal sign on the bottom of that, then you write it as well, right? Okay. Where do you see x values of 1/2? Would be what you're looking for on the unit circle here. Do you see it in those locations? And I need a degree answer. So 60 degrees, is that where you all found it? And 300. So there was 4 angle answers that worked. Okay, number 2. Okay, which of these do we have a replacement for? Can you replace sine squared with something or cos with something? Do you have anything on your formula sheet that you can replace? Because there's no way I can solve a equation that has sine squareds and coses all mixing together. That doesn't work for me. Did you pick sine squared to make a replacement for? Okay, it's at the top. We just did it. So this is my replacement right here. 1 subtract cos squared. Do you notice how I put it in brackets? Because there's still a 2 out of it yet. So I'm going to have to do some work yet. So the t is the variable, so I have to stay with that. If I have an x, if I have a theta, you copy down whatever I have as my variable. So it's the angle t is what we're solving for. Okay, replacement is done. So that's step 1. Step 2 is do some algebra work here. So distributing makes 2 minus 2 cos squared. Do you have 1 variable or 2 variables? 2. So I need a 0. I am going to pick a specific side because my squared unit is the boss, and I know I'm going to have a trinomial. I like to start with a positive. So I'm going to be moving that way to make a 0. I don't like factoring with negative x squared stuff. Does that make sense to you? So think about how it's all going to look. Positive 2 cos squared plus 3 subtract 2. You see how I changed the sign, I kept that, I changed that because the things I move, I change, right? Now, does it factor. So 2 cos t and a 1 cos t have to be there. This and this have to multiply to that. So where do you want to put it so that it will FOIL to be 3? So think about that. It could be a little bit tricky. You're going to put a 1 and a 2 or a 2 and a 1. How are you going to match it up? I need to make sure that and that make a 3. So I did this to be plus 4, subtract 1, that gets me my 3, this gets me my negative 2. Do you see all my foiling pieces? I have to think about all those FOIL pieces backwards in my head though, right? So cos of angle T equals 1/2, positive 1/2. And then cos of T equals negative 2. These are trig values. We haven't even started the angle process. So now, oh, I'm going to do this one first. Why do I want to do that one first? It's easy. What is the answer? No solution for it. Right? Cos can't go out of that negative 1 to 1. Ooh, this one's on the unit circle. This is actually just where we looked, right? We just did a cos of 1/2, so we were right there and there. But how do I answer this time? What does this tell me to answer in? Tell me the angle in radians. So, same spots as that we looked at, except for 60 degrees, we should write pi over 3 as an answer. Okay, the last one here. Which are you going to replace? Is there a replacement for tan squared or secant? And you know what the hint is? The squareds. Look at all this. This is all squared stuff. They always have replacements, the squared parts. So tan squared. Okay, figure out what to replace tan squared with from your sheet. Okay, did everybody pick secant squared minus 1 from their top part of the formula sheet? That was good? Okay, so step 1 was our replacement. Now, I need to do some algebra work here. Okay, distribution happened. Now I have 2 variables, so I'm going to zero one side out. This is the boss. It's positive, so I'm going to leave it. This would get moved. Now it looks like a quadratic in a nice order. I'm going to factor it. I think it's very similar to our last one, right? So I ended up with my negative 4 secants plus 1 secant, and that's how I got to the negative 3. If you can see my negative 4 and a plus 1. Okay, let's get our trig values. So this would be negative 1/2. We will get there. Yeah. You're one step ahead of me. Negative 1/2 and positive 2. So that's where I am. Okay, now Yuri, what? You're ahead of me. Now you can go. What are you going to do? Flip it to what? Secant changes to a cos. So cos of angle T would be negative 2. Cos of T would be 1/2. Oh, look at this. That's the same as our question above. So now this one is no solution. And we're going to answer a little bit differently because of this. Solve for all. What do you do when you do an all? Pi over 3 plus 2 pi k. So same answer from above, but now I need to add the any revolutions to say any answer. Any answer. Okay, which one should we replace? What do you think? Actually, there's cos squareds and sine squareds. So which one do we pick? How do we know?
Sine squared.
Sine squared. Because if I were to replace this, it would insert a sine squared, and then I still have coses. If I replace this, I'm putting cos squareds in there, and I'm looking, and everything would have something with coses. Okay, you need to do it with brackets because there is a subtracting that. So there's still going to be a distribution with our subtract symbol. Does that make sense? Okay, so there's my substitution, and I did it in brackets. So this subtract symbol, that's why I had to do that in brackets, because I need to subtract the unit. So it will go through. Okay, so there's my distribution, right? Now what? What do you want to do with this? It's just algebra stuff? Should I put those together? So 6 okay, I'm going to factor it now. It is a complex, but this has to be a 1 and a 1 at the end, right? There's no other options there. What do you want to do to make this first? Any predictions? Do you want to use a 1 cos times 6 cos, or would you like to try the 3 cos times the 2 cos? Looking into the middle, what are you thinking? 3 and 2, because I'm looking for a -1 on the add. So 3 cos theta and 2 cos theta. So where do you put a negative and positive on this? Because of the FOIL has to make a -1. That's good. We got our FOIL to work out with our factoring. Check. Okay. Cos theta equals negative 1/3. And cos theta equals positive 1/2. Oh my goodness. Apparently this is the common one. Cos of 1/2 again. Let's do that one. We literally just did it 2 other times or 3 other times, didn't we? Okay, so there's the unit circle positions. And what should I do for an answer here? Just on the interval. So I just need a radian answer. Not the plus 2 pi k, right? Just the radian. So we just did it. What was this one? Pi over 3. 5 pi over 3. Now, do you recognize this from the unit circle? No. So all of our steps are different. Okay, step 1. Where? Where is your angle? If you have a cos, that's negative.
Didn't it say 0 and 2? Shouldn't this not be on the range?
2 pi. So it's a full circle. I can go anywhere in the full circle to answer the angle. That makes 2 pi, not 2. 2 pi.
I mean, like, it says 0. Does that mean I can't go below?
You can't go below, so you can't answer me a negative angle. Like you can't answer, like for here, this would be also negative pi over 3. That would be that location, but I can't answer that because it doesn't allow me to answer negative. Okay, did you pick those 2 quadrants? Right? Now, I need to get into the angle. How do you get an angle? If you get the trig value, how do you go to an angle? You inverse. That's how you get to angles, right? And what do I keep preaching to you? Don't use the negatives in the math. Use the negatives in the drawing. And then, what should I do at the top here? Radian mode. Okay, so here's my type. Cos inverse of 1/3 in radian mode. That's how many radians I have in a reference amount, right? Not my answer though. That's just my reference. So I'm going to do pi minus that number, get it, and pi plus that number and get that.